Hello students, so in this video we are going to discuss about sequence, series and sigma notation. So if you remember in lesson 1.1 and 1.3 we studied about order pairs like graphs and order pairs x and y values, and in lesson 1.3 we studied about end behavior. And what is about end behavior? When, if you remember, we studied about when limit x is approaching to infinity and then function f of x is going towards maybe positive infinity, something like this. If you remember, we studied this part. Now what are we going to do? Look, if you notice that whenever you have x values you also have a y values, correct? And if you keep thinking about it, then it will give you some kind of sequence. Okay, so in this lesson we are going to study about how to investigate several different types of sequences. Okay, and later on how can you write sigma notation by using or by calculating the sum of the series. Clear? Now first of all, what is sequence? A sequence is an ordered list of numbers. Okay, like you have different numbers written and then you find the sequence of those numbers. Now we are going to discuss about sequence, then terms. Like term, one sequence have many terms, so let's say I will write it down a sequence 1 2 3 4. Okay, now 1 2 3 4, 1 is a term, 2 is another term, 3 and another term. Okay, so this is a term sequence. This whole thing is a sequence. Clear? All right, next thing is finite sequence. Now finite sequence is when you have some numbers, so like 1 2 3 4, this is a finite sequence. Now what do you say? What is happening in this sequence? We are adding 1 in a previous term. So look, if you add 1 in this first term, you will get the next term. If you will add 1 more in this term, you will get the next term. So it's like you are adding +1 and +1, and this is a finite sequence. And what is infinite sequence? When you present dots. Dots means this sequence is keep going on, it's not stopping anywhere. Clear? So we learned or we understood 4 more vocabulary words, like what is the purpose of these words. Clear? Next is recursive sequence. Now recursive sequence is when a sequence is based on a recursive formula. Okay, what we were doing before in lesson 1.1, let's say if you have a function f of x equals to 2x plus 1, correct? What do? You substitute. Wait, so I was talking about the recursive sequence. So you know, when you have one kind of formula and you keep getting a sequence and that sequence is not stopping, that is called recursive sequence. Like one kind of formula you use to generate a sequence, that is called recursive sequence. Clear? All right, now what are you going to talk about? Explicit sequence, that is again another form of the sequence, so we will talk about this one also. And there are some more vocabulary words which I am going to show you right now, but we are not discussing for today's lesson. I will discuss those things in more details in later. Fibonacci sequence, convergence, divergence, series, finite series, and partial sum. So these are all things we are going to discuss. Clear? These are the vocabulary words we are learning new in this chapter or also in this lesson. Next, so here we have a question. Find the next 4 terms of the sequence. What is the sequence? 3, -1, -5, -9. Now first of all, this is finite sequence or infinite sequence. Decide this. Next, you are going to find 4 terms. Before I start explaining you something like how are you going to find these 4 terms, Pause this video for a second and then try to figure out what are the four terms next. Alright, so if you notice, then from -3 to -1, what is happening? You are subtracting negative. What are you subtracting? It's going to be -4. Clear? Because 3 minus 4 will give you -1. What is happening in the next term? Again, -1. So look, -4. So -1, -4 will give you next term, -5. What is the next term? -9. So again you can see -5 and -4 gives you a next term. So what will be the fifth term of this sequence? What do you do? Sorry. Look, you can see the sequence -9 and -4. You're going to use, and the next term is -13. And then again you will do -4 more, -17, -25. Okay, so what is this sequence? The nth term of this sequence is not given, but the pattern is very easy to figure out. What is happening? Each term is 4 less than the previous term, which I already explained you. So this is how you find the next term. Clear? All right. So let's move to the next question. Here is the answer. Here is the next question. So 18, 15, 10, and 3. Again, pause this video and try to solve this question. Now, 18 to 15. What is happening? You are subtracting 3 from the previous term. 18 minus 3 is 15. What is happening next? -5. Correct? What is happening next term? It's -7, right? So look, what is happening in this term? If you see the sequence in the order, like what you're getting, -3, -5, and -7, you can conclude that we are subtracting an odd number from each previous term. So look, for 18 we subtracted -3. From the next term we subtracted -5, right? In this one, in 10, we subtracted -7. So what do you do in 3? In 3, we will subtract -9. So what will be the next term? It is going to be -6. Clear? So this is how you will figure out what is the next term in the sequence. The difference, look here. Sometimes the difference between two terms can be same, or it can be something else. So like in previous question, the difference was same, like -4, -4, -4. But in this question, difference is a sequence of odd terms. Okay, now look what they are explaining. They're saying if we follow this pattern, that subtract second minus first, you get -3, and then you get -5, and you get -7. So what is happening? It appears that each term is generated by subtracting the next successive odd number. Clear? I hope you guys understood this example also. Now let's see the next question. Here is it, the recursive formula. Okay, now find the first 4 terms of the sequence given by an equals to n cubed plus 1. Now what are you going to do? First 4 terms. Now what do? Is you will just present that n is greater than and equals to 1. When you say that n is greater than and equal to 1, so what do? You replace the values of n. So you will say a1 equals to 1 cubed plus 1. this is equal sign. So first term, a1 present first term of your sequence. Okay, so a1 is equals to 2, and then you will find the second term, a2 equals to 2 cubed plus 1. So a2 is equals to 2 cubed is 8 plus 1 is 9. So this is how you find the first 4 terms by changing the n values in this, and then you are generating a sequence by using this given formula. And once you will substitute the n values, as you can see that in the question it's written only first 4 terms, you will just substitute n equals to 1 2 3 4. You will get all the first all the first 4 terms. So you will have it's right here, answer is 2, which is I found it here, first term is right here, then 9, and then 2. You will find 2 more, that is the answer, 28 and 65. Clear? All right, now this is pause this video, try to solve this question, and once you will solve this question I will show you the answer. Okay, so the answer for this one is A. Clear? So let's move to the next question. All right, again, recursive defined sequence. Again, look at this one. Here, in this case, this is the recursive formula. Okay, and here a1 is given. And here they are presenting that, giving that the range of n. Find the 4th term. Directly, they are telling us to find the 4th term of this sequence. Okay, now to find the 4th term, what do you need to do? Here you will say that n is equals to 4, right? To find the 4th term, because subscripts present the number of the term. So I will say a4 equals to 3a4 again here minus 4 plus 2. Correct? Now you will simplify. A4 equals to 3a, 4 minus 1 is 3, minus 4 plus 2 is 6. Now here's the problem. What about a3? We don't have it. What do? Means you have to go by sequence. You have to find first a2 to get a3, and you will get a3 to get a4. Clear? So you will have you will have a2 equals to 3, and that is going to be a1 minus n is 2, so 2 plus 2. You will simplify this one. A2 equals to 3, a1 is 3, minus 2 plus 2 will become 0, and you will have a2 equals to 9. Clear? Now this term a2 equals to 9 you will use in another formula, which is going to be a3 equals to 3a 3 minus 1 2 minus 3 plus 2. You will have a3 equals to 3 times 9 minus 1, 27, and a3 equals to 27 minus 1 is 26. Now this term of a3 you can use it over here. It's going to be a4 equals to 3 times 26 minus 6. Clear? And then you will have a4 6 times 8 78 minus 6, and you have a4 is equals to 72, and now you found the 4th term. That's it. So this is the simple way, this is how you use these terms to find your final answer. I hope you understood this.